Finite element analysis application to civil engineering. I wanted to talk about this, which is a introduction to this. Now, what are the different types and all? I wanted to tell you. Now you see, finite element analysis. This is just like discretizing the thing. A continuum is split into parts. Again, we are going to combine it. This is what is just to indicate in the form of sketch. He is beating the things. Again, he is combining it. Now, actually speaking, we have classical methods, exact solution, approximate solution. Here, numerical method, energy, boundary element, finite difference, finite element. Now you come to the methods of solution. We have classical method, that's what I explained, but they offer very high degree of insight, but the problem difficult or impossible to solve anything but simple geometry loadings. This is what energy, boundary element, all you can go through. But exactly the finite element, it's a numerical technique for solving partial differential equations PDEs. It reduces PDE complete of the system to algebraic equations which can be solved using traditional linear algebra techniques. In simple terms, FEM is a method of dividing up a very complicated problem into small elements that can be solved in relation to each other. Advantages: models bodies of complex shapes, can handle general loading, boundary conditions. Bodies are composed of composite, multi-phase materials. Model is easily refined for improved accuracy and varying different for variations also. Element size, type, approximation scheme, time dependent and dynamic effects, can handle a variety of problems. Non-linear also very important. Behavior, large deformations, boundary conditions, all that we can handle. Now you go to applications are stress analysis, truss and frame in our civil engineering. Stresses, bulking is a very important columns. It is buckling, vibration analysis, impact. Heat transfer is a non-structural element. Fluid mechanics, electric and magnetic or potentials. Historical background is very interesting. It is from 1940. Structural engineering, one-dimensional element. 1950, direct stiffness method, two-dimensional elements. 1960, they coined the term finite element. 1970, three-dimensional elements, large deflection, thermal analysis. 76, large deformation, non-linear dynamics. Presently, we are having new elements, new softwares. General steps are: first we have to discretize, select the element types, select a displacement function, define the strain displacement, stress strain relation, derive the element stiffness matrix, equations, assemble element equations to get global and introduce BCs, that is boundary conditions, solve for the unknown degrees of freedom, solve for the element strains and stresses, interpret the results.